So let's go ahead and get started. Today's lecture, we are going to talk about the Portland cement concrete, but this time we are going to talk about the processes associated with the Portland cement concrete. For example, the mixing of the concrete, the placing of the concrete, and handling of the fresh concrete and the curing process. In the previous lecture, we learned how to come up with the concrete design. But now, after we finish from the concrete design, we need to understand the processes associated with the concrete design. So in this figure here, we'll be able to understand the activities involved in the construction process of the concrete structure. The first process, we need to come up with the mix design, the proportioning. In the previous lecture, we learned how to come up with the proportioning. The mix in the proportioning, we are going to know how much sand we are going to use, how much gravel, how much cement, how much water, how much admixtures. Then after theoretically find the proportioning, then we need to have trial mixes to make sure that the properties is going to meet our requirements. And after this, we are going to start the batching process. In the batching process, we are going to measure the cement and the aggregate and the gravel and the water, and then introduce them into the mixer. We call this batching. So in the batching, we need to measure all the quantities. And after we measure all the quantities and put the quantities inside the mixer, then we are going to start the clock. Because at this process, we are going to, after this process of batching, we are going to start the mixing process. So we need to start the clock because we need to know the value of the initial set and the final set. So after the batching process, we are going to start the clock in order to determine the initial set and the final set. Now, after the batching, we are going to start the mixing process. In the mixing process, we are gonna mix all the ingredients of the concrete until they became uniform in appearance. Then after we finish the mixing process, we need to transport the concrete to the job site. Then after transporting the concrete to the job site, we need to place the concrete inside the structural elements. And during this process, we need to take sampling and we need to test the concrete. Mainly, we need to test the slump and the air content, and also we need to take sample, cylindrical and flexural or beam sample, so that we determine the flexural strength and the compressive strength of the concrete. After we place the concrete inside the structural members, then we are going to start the vibrating process or the consolidating process. In this process, we are going to vibrate the concrete so that we can get rid of the air voids. And if we don't get of the air voids, we are going to have a problems called honeycomb. These processes, all these processes should be done before the initial set. We know the initial set because we have done the test. We determine the initial test and the final test. These processes should be done before the initial set. That is why we said here we need to start the clock. Then between the initial and the final set, the finishing process should be done. In the finishing process, we'll make sure that the surface is smooth and it's level. In the finishing process, the finishing process should be done before the final time. In the initial time, the concrete is going to start to lose its plasticity properties, and in the final set, the concrete has become completely hardened. So the finishing process should be done before the final set, and these processes should be done before the initial set. The initial set of the concrete is going to be between 1 to 3 hours, and the final set, it could be between maybe 10 to 16 hours. Then after we finish, after the concrete completely hardened, then we are going to start the curing process. In the curing process, we are going to maintain a certain level of moisture and temperature so that the concrete is going to gain its ultimate strength. Even though the concrete here is hardened, but we need the curing process in order to increase the strength of the concrete by maintaining a certain amount of moisture and temperature. Then after a while, if you have a problem with the concrete, you may need maintenance. So I'm gonna walk you through these processes. We already talked about the mix design and trial mixes. So in this lecture, we are gonna know what does it mean by batching, what the conditions for the batching, and which method is going to be the best. Also, we'll talk about the mixing, transporting, pouring, or placing of the concrete, vibrating, finishing, and the curing process. So why these processes is important for us, mixing, placing, and handling of the fresh concrete? Because the proper batching, mixing, and handling of the fresh concrete are important prerequisite for strong and durable concrete structures. So in order to get strong and durable concrete structure, we should have proper batching, mixing, and handling of fresh concrete. There are several steps and precautions that must be followed in mixing and handling fresh concrete in order to ensure a quality material with the desired characteristics. We design the concrete in order to get desired characteristics. And in order to get these desired characteristics, we should follow the precautions regarding the mixing and handling of the fresh concrete. The first process is batching. Batching is the measuring of concrete ingredients, like measuring the sand, gravel, water, and the cement, and then introduce these gradients into the mixer. The batching, it could be done by the weight, or it could be done by the volume. But batching by weight is more accurate than the volume, because batching by weight does not include air voids. While the batching by the volume, the air voids is going to create problem for me. So batching by weight is more accurate. Also, we have the mixing process. In the mixing process, we are going to mix all the gradients of the concrete together. And the concrete should be mixed thoroughly, completely should be mixed. And the mixing, it could be made using a mixer, or it could be by hand. We are going to mix until the concrete becomes uniform in appearance. We are gonna mix the ingredients together until we have a uniform appearance of the concrete. We said here the mix, it could be done by a mixer or by hand. Hand mixing is usually limited to small jobs. If you have small jobs, then it's preferred to use mixing by hand, or in situation in which mechanical mixers are not available. If you have a situation where you don't have availability of mechanical mixer, then you could use hand mixing. Regarding the mechanical mixers, that include on-site mixers and central mixes in ready mix plants. Also, we're going to talk about the ready mix plants. And the capacity of the mechanical mixer varies from 1.5 cubic meters to 9 cubic meters. And the mixing time and the number of revolutions vary with the size and the type of the mixer. Usually have a minimum of 1 minute of mixing for stationary mixers up to 0.75 cubic meter. And during the mixing, we are not going to put all the water, but we are going to start with 10% of the water in the mixer. Then we are going to put all the solids. Then with the solid, we are going to put 80% of the water. Finally, we are going to put the remaining water. So we are not going to put all the water together. This process is going to help me to get a uniform appearance of the concrete. Also, we are going to hear a lot about the ready mix concrete. So what does it mean by ready mix concrete? When we say ready mix concrete, it means that the concrete mixed in a central plant and then delivered to the job site in a mixing trucks ready for placing. So when we say ready mix concrete, that means the concrete is going to be mixed in a central plant. Usually is going to be around the town or the city that you live in. Then this concrete is going to be delivered to the job site in trucks, ready for placing. And we have 3 mixing methods can be used for ready mix concrete. In the ready mix concrete, the mix could be, we could use the central mixed or the shrink mixed or the truck mixed. In case of central mixed, the concrete is mixed completely in a stationary mixer and delivered in agitator truck. This one is going to rotate the rotation between 2 revolution per minute to 6 revolution per minute. Or the mixing could be done using the shrink mixed. In the shrink mix, the concrete is partially mixed in the stationary mixer and completed in the mixer truck. So this process is going to be start in the stationary mixer and then to be completed in the mixer truck. And in this case, the truck is going to rotate between 4 revolutions per minute to 16 revolutions per minute. Finally, we have the truck mixed. In case of the truck mix, the concrete is mixed completely in the mixer truck. And the rotation of the mixer is going to be between 4 revolutions per minute to 16 revolutions per minute. So we have 3 cases regarding the ready mix concrete. Either to be completely mixed in the central plant or partially between the truck and central plant or completely to be mixed in the truck. And it's worth noting that the concrete should be discharged at the job site within 90 minutes from the start of the mixing. So within 1 hour and a half, we should deliver the concrete from the job site, from the ready mix plant to the job site within 90 minutes. Even if retarders are used. Remember the retarders admixtures? These retarders help us to delay the setting time. Even if we use retarders, the concrete should be delivered to the job site within 90 minutes. Otherwise, you should reject the concrete. Here we have a picture for central batch concrete plant. Okay, here we have the mixer located here, and here we have the drop shot. In the drop shot here, the truck is going to be here so that the concrete is going to be discharged to the truck. Here we have the water tanks. Here we have the aggregate bins. We have the sands and the gravel. And here we have the cement silos. And also we have silos for admixtures. So here we have the room control. We are going to control the amount which is going to be introduced to the mixer. So here we are going to start the batching process. This facility is going to measure all the required amount, and then all of these ingredients is going to be introduced to the mixer. Then the mix is going to mix the concrete using one of these methods: central mixed, shrink mix, or trunk mixed. Then the concrete is going to be delivered to the truck, and the truck is going to deliver the concrete to the job site. Also, we have the mobile batcher mixed concrete. In the mobile batcher, this truck is going to introduce all the ingredients to the mixer, a special mixer here, and through this one we are going to deliver the concrete to the job site. So in this truck, we have here we put the sand and the aggregates. Here we put the sand and the aggregates. Here we have a water tank, and here we have the cement, and here we have the mixer. The mixer, we are going to introduce all the ingredients into the mixer, and then here we have the discharge shot. So concrete can also be mixed in a mobile batcher mix at the job site. Aggregates, cement, water, and admixtures are fed continuously by volume, and the concrete is usually pumped into the forms. Also, regarding the depositing concrete, when we deliver the concrete to the job site, we need to deposit the concrete into the structural members, the columns, the beams, the slabs. And we have several methods are available to deposit concrete at the job site. Now the concrete has been delivered using the truck. Then how to deliver the concrete into the structural members. So we have many methods to do that. It could be directly into the form like this one, or we could use the wheel bro. We are going to put the concrete in the wheel bro, or we can deliver the concrete using the bucket, this one, or we can deliver the concrete using the pump. And in all these cases, we should deposit the concrete continuously. We should not stop. We should continuously deposit the concrete. And this distance, it should be as close as possible. This distance should be as close as possible because segregation is going to take place. And advanced planning and good workmanship are essential to reduce delay, early stiffening, and drying out, and segregation. So this process is very important. Also, we have the pump concrete here. We have the bump concrete. In the bump concrete, the concrete is going to be a deposit using a pump. Here we have this bump here. We are going to use this bump in order to deliver the concrete to its final position. So you can see the bump. This one facilitates the work right now, and especially in the large construction project. So pump concrete is frequently used for large construction projects. This facilitates the process of depositing the concrete. But when you use pump concrete, careful attention must be exercised to ensure well-mixed concrete with a proper workability. We should take care about the workability. And the slump should be between 40 millimeter to 100 millimeter before bumping. Before bumping, we make sure that the slump at least to be between this range. Why we do that? Because during bumping, the slump decreases by about 12 millimeter to 25 millimeter due to partial compaction. Because when we use bump, then we are going to have a type of compaction during the process of bumping the concrete. So we are going to lose the slump. The slump is going to decrease by this value. That is why before start using the bump, we should make sure that the slump between 40 millimeter to 100 millimeter. And also we have problems associated with the bump concrete, like the blockage. The blockage could happen during pumping due to either the escape of water through the voids in the mix or due to friction if fines content is too high. So we should pay attention to that problem here if you are going to use pump concrete. Here we have picture for pump concrete. Here's a truck. We use this truck in order to bump the bumper. We are gonna bump the concrete from the truck using this pump, and then you can see that the pump it could have the ability to move like that, which facilitates a lot of construction work. And this distance here should be as close as possible, like we mentioned before. Then after we place the concrete, after we deposit the concrete to its final position, we should start the vibration of the concrete or the consolidation of the concrete. So in order to have a good quality of concrete, vibration is required. So quality concrete requires thorough or complete consolidation to reduce the entrapped air in the mix. And remember, this process should be complete before the initial set time. So why we do vibration? In order to reduce the entrapped air. If you have a small job, consolidation can be accomplished manually using ramming and taping of the concrete. Like this guy here, he uses a stick in order to vibrate the concrete. If you have a small job. But regarding large job, we are going to use the vibrators. This one is the vibrators. We need to use these vibrators in order to consolidate the concrete. And the internal vibrators are the most common type used on construction projects. These internal vibrators. We have conditions regarding the vibrators. The vibrations should be between 5 seconds to 2 minutes on one spot. On one area, the vibration between 5 seconds to 2 minutes. Typically, the vibration time should be less than 10 seconds. And the operator judge the total vibration time required, and we should avoid segregation. In the case of the segregation, the mortar migrate to the surface and the solid is going to settle down. That we call this segregation. So we should avoid segregation. The vibration should be through the entire depth of the structural member and should penetrate layer below if still plastic. And over vibration, if you are going to vibrate the concrete more than the required, we are going to have segregation as the mortar migrate to the surface. Poor consolidation can result in something called honeycombs. If we have poor consolidation, if we are not going to consolidate the concrete in a proper way, then we are going to have something called honeycombs. Honeycombs look like that. We are going to have voids because in consolidation, we need to get rid of these voids. So if you have done poor consolidation, we are going to have these voids here. And these voids is dangerous because these voids are going to cause early corrosion of reinforcing steel and low compressive strength. And honeycombs are hollow spaces like this one, and cavities left on concrete mass on surface or inside the concrete mass where concrete could not reach. And these we call them honeycombs because they look like honeybee's nest. That is why we call them honeycombs. Then we need to take sampling and testing. We are going to have test on the site, and also we are going to prepare sample for later testing. On the site, we need to measure the slump, and also we need to measure the air content. And we are going to take also samples to test samples of cylinders and beams. The cylinders in order to measure the compressive strength, and the beam in order to measure the flexural strength. Regarding the slump test, the workability of the concrete mainly measured by the slump test. That is why the slump test is very important test. When the truck is going to deliver the concrete, we are going to take amount of concrete in order to conduct a slump test. And the slump test is going to be done according to ASTM C143. And the slump test is the most generally accepted method used to measure the consistency of the concrete and the workability of the concrete. So in the slump test, we need equipment. We have we need to have the slump cone. This one we call slump cone. And this slump cone it has a height of 300 meters, the height of the cone. And we have two diameters. We have the base diameter and we have the top diameter. The top diameter is 100 millimeter and the base diameter is 200 millimeter. Then we are going to fill this cone with concrete in 3 layers. The first layer, the second layer, and the third layer. Each and every layer is going to be rodded 25 rods. So this one, we are gonna have 25 rods for each layer. Then the cone is left. We're going to lift this cone, leaving the concrete like that. Then the concrete is going to be like that. Then we need to measure the distance from from here to here. This distance represents the slump. So like you can see here, the cone has been filled with the concrete in 3 layers with 25 blows. And then we measure the difference between the initial height of the cone and the final height of the concrete. We call this slump. A higher slump value is indicative of more fluid concrete. When the value of the slump is high, that means the workability is high. That means the concrete is more fluid. The entire test through removal of the cone should be completed in 2.5 minutes because the concrete loses slump with time. So within 2 minutes, we should finish the test. Also, we have the measuring air content in fresh concrete. Also, we need to measure the air content in the fresh concrete, and the air content can be measured using the pressure method or volumetric method or gravimetric method or case air indicator methods. The pressure method is widely used since it takes less time than the volumetric method. So the pressure method, the most used one is the pressure method because it takes less time than the volumetric method. And this one based on the Boyd's law, which relate the pressure to the volume. In this test, we are going to use a calibrated cylinder. We call this calibrated cylinder, and this cylinder should be filled with fresh concrete. So we are going to open this device, fill the concrete with, fill this cylinder with concrete, and then close it. The vessels is capped and air pressure is applied. Then we are going to cap the cylinder, okay, and then we are going to apply a pressure. For the fresh, the concrete is going to be here. We are gonna cap the cylinder with this device, close the cylinder, and then through this device we are going to apply a pressure to the fresh concrete. Of course, when we apply pressure to the concrete, then the applied pressure compresses the air in the voids of the concrete. So when we apply pressure, if we have air, then the concrete is going to be compressed. And the volume of air voids is determined by measuring the amount of volume reduced by the pressure applied. When we applied pressure, then the volume of the concrete is going to be reduced because of the pressure, and we have air voids. Then we are going to measure the reduced volume. This reduced volume represents the air content. This process also, it could be done using the volumetric method. In the volumetric method, we are going to use this volume cylinder. This volume cylinder is used for the volumetric method. We are going to deliver the concrete inside this cylinder to a certain limit. Let's say this limit here. And then we are going to fill the cylinder with equivalent amount of water. So let's say that we put concrete to this level. Then we are going to fill this one with the water with the same amount of the concrete. And then here we are going to measure the level of the water. And also we are going to agitate the cylinder. So agitation of the cylinder of the container allow excess water to displace the air in the cement paste void. Then when we put the water and we agitate the cylinder, then the voids is going to displace in the air. And the water level in the container, after this process, the water level in the container falls as air rises to the top of the container. Because here, when we agitate the cylinder, and here we have the water, then the air void is going to rise to the top. And then the level of the water here is going to fall. Thus, the volume of air in the cement paste is directly measured. So then, after the disappearance of the airs, then we can measure the air content. Finally, we are going to prepare samples for cylinders samples and also beams samples. We are going to measure, prepare cylinder samples in order to test the compressive strength. We could use the cylinder or we could use the cubes. The cylinder is going to have a diameter of 150 millimeter and a height of 300 millimeter. So the height of the cylinder is going to be 300 millimeter and the diameter is going to be 150 millimeter. Or if you are going to use cube, the side, one side of the cube is going to be 100 millimeter, or we could use 150 millimeter cubes. Again, here we have the cylinders. Here we have the cylinders. This guy, this engineer is going to prepare cylinders at the job site. And again, the cylinder should be filled in 3 layers. And each and every layer is going to be rode 25 times. And of course, in the lab, we are going to see this. And then we are going to cover the mold with a wet cloth to prevent evaporation. And then we are going to remove the molds after 16 hours. So this cylinder's molds is going to be removed after 16 hours to 23 hours. And you should cure the specimen in a moist cabinet or room at a relative humidity of not less than 95% and a temperature of 23 plus or minus 1.7 degrees Celsius, or submerged in lime water to finish the curing process. So I'm going to stop here. Next time, I'm going to talk about the spreading and finishing of the concrete, the finishing process. If you have any questions, please ask me. So now we need to talk about how to spread and finish the concrete. We have different methods are available to spread and finish concrete. It depends on the nature of the structure and the available equipment. So I have many ways in order to spread and finish the concrete. Which one is going to be used? It depends on the structure and the available equipment. Here we have many equipment. I think you have seen most of this. We have the hand floats. We have these hand floats. We use the hand floats in order to help us to spread the concrete and to finish the external surface. Also, if you have good equipment, you can use a power float. You see the man here, he used power float so that he can spread and finish the concrete. Also, we have the vibratory screed, this one here. This one is a good tool in order to spread and finish the concrete. Here we have the mechanical straight edge, like this one. So this one is mechanical. And of course, this one is good when you have the area of the slab is large. Also here we have a straight edge. This one is a manual straight edge, and this one is mechanical straight edge. Also we have the normal trowel. You can use the normal trowel in order to finish the concrete, but this one is going to be limited to small jobs. Here we have this machine here. Through this machine, we are going to place the concrete pavement. You know that the pavement is not going to only to be produced with asphalt concrete. Also, we can produce pavement using the Portland cement concrete. And in order to do that, we are going to use this machine here in order to spread and finish the concrete. So now we are going to talk about the last step, the curing of the concrete. So what does it mean by curing? Curing is a process of maintaining satisfactory moisture content and temperature. So I'm going to maintain a certain level of moisture and temperature in the concrete for a definite period of time. So why we should do that? Because hydration of the concrete is a long-term process, and that requires water and proper temperature. We talk about the hydration process. We say that when the concrete come in contact with the cement, a hydration process is going to take place. And this process is a long-term process. So in order for this process to continue, I need to maintain a proper amount of water and temperature. So the benefit of the curing of the concrete, the curing is going to allow continued hydration. The hydration process is going to be continued, and as a result, that the concrete is going to gain strength. So if I'm going to provide the concrete with a curing process, the result is the strength of the concrete is going to increase. In fact, once curing stops, the concrete dries out and the strength again stops. So once you stop the hydration curing process, then the hydration process is going to stop, and as a result, the strength again is going to stop as well. Here we have this figure. This figure is going to help you to understand the curing process. In the y-axis, we have the compressive strength, and in the x-axis, we have the age by days. So here we have many scenarios. The first scenarios, the specimen has not been applied to curing process, which means that the specimen has been in the air in the entire time. In scenario number 2, the specimen was in the air after 3 days. So this one, we apply curing for 3 days only. And this specimen here, we apply curing for 7 days. And this one here, the last sample, the curing process has been applied for the entire period of the graph, which is 180 days. We want to see the effect on the strength. So, like you can see here, if you are going to compare, compare this sample with that sample. This sample has been put in the air the entire time, so no curing has been. The curing has not took place here. While this one, we have curing for 7 days. So if the concrete is not cured and is allowed to dry out in the air, it will gain only about 50% of the strength of continuously cured concrete. So now, if we are going to say that after 28 days, the value of the strength is almost 50%, while this one, which has been put in the curing for the entire period, which is 28 days, the value here is 100 megapascal, which means that I lost 50% of the strength. Also, if the concrete is cured for only 3 days, this one is only for 3 days, it will reach about 60%. So this value, you can say almost 60% of that value if you are going to cure the concrete for 3 days. And if you cure the concrete for 7 days, it can reach about 80% of the ultimate strength. So you can see the difference here. This sample, it has not been cured at all. This one, it has been cured for 3 days. This one, it has been cured for 7 days. This one, it has been cured for 28 days for the entire period. And you can see the difference in the strength gain. If curing is stopped for some times and then resume again, so if you stop curing and then you start the curing process again, the strength gain will also stop and reactivate it as long as you are going to reactivate the curing process again. So this figure is a good way in order to understand the curing process of the concrete. So the proper curing not only strength, but also provide other desirable properties such as durability, water tightness, abrasion resistance, volume stability, resistant to freezing and thaw, and resistant to de-icing chemicals. Curing should start after the final set. So of course you need to start the curing after the final set when the concrete has been hardened. If the concrete is not cured after setting, the concrete will shrink, causing cracks. So again, the curing is not only good for strength, but it's good for other properties. An example for improper curing would be a concrete floor built directly over the subgrade. You know, the subgrade not cure at the surface with the moisture in the soil curing it from the bottom. In this case, the concrete slab may curl due to the relative difference in shrinkage. So if you have, let's say, a slab, and that slab, it has been built on subgrade, and at the surface, no cure has been applied at all. But the subgrade, we have the soil, and the soil, it has a moisture, so the moisture is going to cure the bottom. So in this case, the bottom has been cured while the surface has not been cured. So that is going to curl the slab because of the shrinkage. So how we are going to cure the concrete? We have 3 ways in order to cure the concrete. The first way, we need to maintain the presence of the water in the concrete. The second method, or the second approach, we are going to seal the surface so that the mixed water cannot escape. The third method, we are going to apply heat and additional moisture. So which method should I use? In order to choose which method, I need to put in my consideration the following.
First, the size and the shape of the structure, the economics and the speed of the application, and the weather conditions. So the method, we are going to start with the first one. We are going to maintain the presence of the water in the concrete. The methods to maintain the water presence include ponding or immersion. We have the spraying or the fogging, and we have the wet covering. Start with the first one, the wet covering. I think this is the most famous one. We are going to cover the concrete with a burlap. This is a burlap, and then we are going to spread water. The burlap is going to help us to maintain the water for a long period of time. So if you are going to use the wet covering, which means that the moisture retaining fabric covering saturated with the water, such as burlap, this one here, or cotton mats and rigs are used in many applications. The fabric can be kept wet either by periodic watering or covering fabric with polyethylene film to retain the moisture. The second method is spraying or fogging. This one here is the second method. In this method, we are going to use a system of nozzles or sprayers can be used to provide continuous spraying or fogging. So here we are going to provide fogging to make sure that the water content in the air is not going to change. And this method here, the spraying or the fogging, require a large amount of water and it could be expensive. And it's most suitable in high temperature and low humidity environment. So if your area have high temperature or low humidity, this one is going to be a good method in order to start the curing process for the concrete. Also, we have the bonding or immersion. You've seen this one in the lab. In this method, we are going to bond the concrete inside swimming pool like this one, a small swimming pool like this one. And in the reality, I'm going to make these barriers, and then I'm going to put the water here. It's just like immersing the slab inside the swimming pool. So ponding involving covering the exposed surface of the concrete structure with the water. So the concrete surface is going to be covered with the water. Bonding can be achieved by forming earth discs. This one is the earth discs around the concrete surface to retain the water, so the water is not going to spread out. And this method is suitable for flat surfaces such as floor and pavement. So for example, I cannot apply this method in order to cure a column. So this one method is suitable for flat surfaces, especially for small jobs. And the method requires intensive labor and supervision. Immersion is also, we are going to use the immersion in order to cure test specimen in the laboratory. So in the laboratory, you are going to use the bonding or the immersion method. Now we are going to talk about the second approach. In the second approach, you are going to seal the surface of the concrete. And why you should seal the surface of the concrete? In order to prevent the mixing water from evaporating. In this method, we could use the membranes forming compounds. We could leave the forms in the place. We are not going to read the form. And also we could use impervious paper or plastic sheets. So here we have the membranes forming compounds, the chemical compound. I'm going to spray this around my structure, and the water will not be able to escape. Or I could use impervious paper or plastic sheets like this one here. And also I could put the form in place. I'm not going to read the form so that the water is not going to escape. But you need to remember this. Preventing loss of mixing water from the concrete by sealing the surface is not as effective as maintaining the presence of the water in the concrete during early ages. So this method here, sealing the surface, is not as effective as the first method, which is maintaining the presence of the water. The last method, we are going to apply heat and additional moisture. So we are going to increase the heat in order to drive hydration. We know that hydration is a chemical process. So if we are going to increase the heat around, the process is going to increase as well. But you need to add moisture. You need to keep the moisture of the environment. And that is good for early strength gain and for when casting in freezing weather. if you are casting the freezing weather, this method is good because you cannot apply the first and the second method. Again, this method is not as effective as approaches 1 and 2. And this one is usually performed in precast plant only. Precast plant, which means that I'm going to cast the concrete ahead of the project. So, for example, I'm going to cast beam and columns in a factory, then I'm going to deliver them into the job site. And in this case, this method is suitable. One of these methods is a steam curing. The steam curing is used when air strength gain in the concrete is required or additional heat is needed during the cold weather. So I'm going to use steam in order to cure the concrete. So using steam, I'm going to provide heat and also I'm going to provide moisture. Also, I have insulating blankets or covers. When the temperature falls below freezing, concrete should be insulated. So this method, again, all of the approach number 3 is targeting casting in freezing weather. The last one is electrical or hot oil and infrared curing. Electrical curing includes electrically heated steel form. So you are going to use steel form that is can be heated using the electricity. So steel forms can be also heated by circulating hot oil around the outside of the structure, and the infrared rays have been used for concrete curing on limited basis. So now here we have a different method in order to cure the concrete. Which one should be used? It depends on the type of the structure. It depends on the environment around your structure. I'm going to stop here. Is a question for you to think about it. Why is extra water harmful to fresh concrete, but good for concrete after reaches its final set? If you do remember, we say that increasing the water content is going to be harmful for the concrete. But now we are going to say that we need to have water so that the strength is going to gain. So why is extra water harmful to fresh concrete but good for concrete after reaches its final set? Think about it. Here we have the answer for that. I'm going to stop here. So if you have any questions, please ask me.